Welcome back, everybody, for another deep dive. This time, we're going to be exploring the world of hemodynamic monitoring.
Sounds intense.
It is, but it's also super fascinating. We're talking about the technology that allows doctors to measure pressures inside the heart and blood vessels, in critical care units.
Right. Real-time vitals, high-stakes stuff.
Exactly.
Yeah.
And what's cool is that even if you're not a medical professional, understanding this stuff gives you a peek into how these systems work and how even tiny errors can have a huge impact. For this deep dive, we're going to be using a medical training document.
Okay.
Which I think is perfect because it lays out everything step by step. It even goes into what can go wrong and how to fix it. Super helpful.
Yeah, those practical tips can be lifesavers, literally, sometimes.
So before we dive into the nitty-gritty, let's start with the basics. What exactly outcasts hemodynamics?
Yeah.
And why is monitoring it so important, especially in critical care?
Well, hemodynamics is basically the study of how blood flows through the body, the forces involved and all that. And in critical care, you're dealing with patients whose cardiovascular systems are, really under stress.
Yeah, think heart attack or shock.
Exactly. So hemodynamic monitoring lets doctors see how the heart's coping, how well medications are working, are there any sudden changes that need immediate action?
It's pretty amazing that our source emphasizes that this isn't some kind of obscure science happening in a few labs somewhere. It's routine in critical care units all over the place.
Oh, absolutely. It's become a cornerstone of critical care.
So how does it actually work? I mean, how do they measure these pressures?
Well, there are a few ways to do it. The most common method uses a fluid-filled system connected to a transducer.
Oh, you know what? When I see those wavy lines on a hospital monitor, the ones that go up and down with a heartbeat, I always wonder, what are those really showing?
Yeah, good point. Those lines are a visual representation of the pressure changes happening inside the heart or blood vessels.
Okay.
It all starts with a thin tube called a catheter. It's inserted into a blood vessel or heart chamber and acts as a sensor. It picks up pressure changes and transmits them through extension tubing to the transducer.
So it's kind of like a miniature plumbing system for the heart.
That's a great way to think about it. The catheter is like the initial sensor in the system. Now, the transducer is the key player here. It converts that pressure, which is a mechanical force, into an electrical signal that a monitor can read.
I see.
And there are two main types: reusable and disposable.
I bet disposable transducers have made things a lot easier in terms of infection control and, just convenience.
Oh, for sure. They're smaller, more durable, accurate, and way more cost-effective than reusable ones. Both types work similarly, though.
Okay.
Inside the transducer, there's a diaphragm that's sensitive to pressure. It's enclosed in a dome filled with fluid. When the patient's heart beats, those pressure changes travel through the fluid and hit that diaphragm, causing it to move. And that movement creates a tiny electrical signal.
Got it. So we've got this tiny signal. What happens to it next?
Well, that's where the amplifier comes in. It takes that weak signal, boosts it to a level that's clinically useful, and filters out any noise along the way.
Okay.
Then that amplified signal goes to a monitor, which shows you the pressure waveform in real time, and often also to a recorder that documents it for later analysis.
Our source mentions this automatic flush device and a pressure bag. What do those do?
Those are essential. They keep the whole system working properly, like keeping the pipes clean.
Okay.
The pressure bag has saline solution, sometimes with heparin to prevent clotting. It's constantly pushed through the catheter and tubing.
I see.
This keeps blood from backing up and clotting in the catheter, so you get accurate readings.
It's pretty amazing how much precision goes into all this. I mean, I never realized how important it was to, prevent air bubbles.
Oh, yeah. Tiny things can make a big difference.
And, our source also talks about square wave testing. What's that all about?
Oh, that's a good question. Square wave testing is basically a quality control check. It makes sure the system is accurately representing the pressure waveform.
Got it.
It's like sending a brief, square-shaped pressure pulse through the system and seeing how it responds.
Yeah.
It's making sure the natural frequency and damping characteristics are within acceptable limits. And that brings us to the concept of hydrodynamic pressure.
Okay, things are getting interesting.
Right. So the pressure we're measuring is hydrodynamic, which means it's constantly changing because of, the beating heart. But this constant change introduces a challenge. Inertia.
Inertia, like from physics class.
Exactly. Inertia is that tendency of an object to resist changes in motion.
Right.
So in this case, the fluid in the monitoring system can't keep up perfectly with the rapid pressure changes caused by the heartbeat.
Oh, I see.
It's kind of like trying to measure a moving target, but the fluid lags a bit behind.
And that can mess up the readings.
It can lead to inaccuracies, yeah. And to understand those inaccuracies, we need to talk about natural frequency and damping.
Okay, hit me with some physics.
All right. Think of a guitar string. When you pluck it, it vibrates at a specific frequency, right?
Right.
That's its natural frequency. It's determined by the string's mass and tension. Similarly, the fluid in our monitoring system has a natural frequency, influenced by the length and stiffness of the tubing.
So if the tubing is too long or too flexible, it's like having a loose guitar string. The vibrations won't be as precise.
Exactly. Now, damping is like if you lightly touch that vibrating string,
Okay.
it reduces the energy of the vibrations so they die out quicker.
Right.
And in our system, damping occurs because of friction in the tubing and the absorption of energy by the system's components.
So too much damping would be like pressing down too hard on the string. It muffles the sound.
That's a good analogy. And both underdamping and overdamping can distort the pressure waveform, leading to inaccurate readings.
So what causes those damping problems and how do you fix them?
Well, the usual culprits are excessively long tubing, air bubbles in the system, blood clots obstructing the catheter, things like that.
Makes sense.
Luckily, most of these are easy to fix. Use shorter, stiffer catheters, minimize the number of stopcocks, regularly check for air bubbles, and flush the system if you suspect an obstruction.
So keeping things clean, clear, and compact is key.
You got it.
I remember our source mentioning that standard hemodynamic values come from healthy individuals lying flat on their backs. In the supine position. Does that mean the patient's position matters too?
Oh, absolutely. The supine position is like the gold standard for accurate pressure readings. Even slightly raising the head or chest can affect those measurements. And that's where another important step comes in. Zeroing the transducer.
Okay, what is that?
It's basically calibrating the system to make sure we're getting the true pressure reading.
So like setting a scale to 0 before you weigh something.
Exactly. We do it by aligning the transducer to the same vertical plane as the tip of the catheter, usually at the level of the patient's heart. That way, we eliminate the effects of atmospheric pressure, which can really skew the readings.
Wow. It's amazing how much attention to detail goes into this whole process. It's not just about the technology itself. It's understanding all these other things that can affect the readings.
You're absolutely right. It's a combination of the tech and the technique. And that's what makes it so fascinating and challenging. It really is. We've talked about the different components, the physics behind the pressure changes, and some practical troubleshooting tips. But it's important to remember that so many things can influence the accuracy of these measurements, from patient positioning to how carefully you calibrate everything.
So for someone who might come across this technology, like as a patient or a worried family member, what does all this mean for them?
Well, I think it means that knowledge is power. Even just understanding the basics of hemodynamic monitoring, it empowers you to ask good questions, to advocate for the care of your loved one, Yeah.
You might even spot inconsistencies that could signal a problem. Like, remember, even small changes in position can change those readings, so don't hesitate to ask about the setup, the procedures they're using.
That's great advice. It reminds us that healthcare is really a partnership.
It is.
And knowing about the tools involved helps us participate more actively in our own care. Or, the care of a loved one.
Exactly. And this knowledge goes beyond the hospital setting, too. I mean, technology is advancing so quickly.
Right.
We're seeing more portable hemodynamic monitoring devices being used in outpatient settings, even at home.
So this isn't just limited to ICUs anymore.
Not at all. We're moving towards a future where continuous hemodynamic monitoring could be as normal as wearing a smartwatch.
Wow.
Imagine being able to track your blood pressure and heart function in real time.
That's pretty amazing.
Yeah. It would allow for early detection of problems and personalized interventions.
That sounds almost futuristic, but exciting.
It is exciting. But, it brings up some important questions, too.
As this technology becomes more common, we have to make sure it's being used ethically and responsibly.
Right, especially when it comes to things like data privacy.
Exactly. Data privacy, how we interpret the data, access to care based on the data, all of that.
That's a really good point. Like any powerful tool, we have to think about the benefits and the risks.
Absolutely.
And I think it emphasizes the need for, education and dialogue as these advances continue to happen.
I agree. Technology can provide amazing insights and potentially save lives for sure.
Yeah.
But in the end, it's up to us as individuals and as a society to make sure it's being developed and used in a way that benefits everyone.
I feel like we've covered so much ground in this deep dive, but we've only just scratched the surface when it comes to the world of hemodynamic monitoring.
You're right. We've been mainly focusing on those traditional fluid-filled systems, but there are other incredible technologies emerging. Like, have you heard of fiber optic monitoring systems?
I haven't.
They use probes with transducers right at the tip of the catheter.
Oh, wow.
Yeah. Which offers even greater precision and miniaturization.
That's incredible.
But of course, they have their own set of challenges too.
So we have these new technologies coming up, along with ethical and societal implications to think about. It seems like we're on the verge of a big shift in how we understand and manage cardiovascular health.
We are. It's a really exciting time to be working in this field, and I encourage everyone to stay curious, keep learning about these advances.
Yeah.
Who knows what breakthroughs are just around the corner?
It's a good reminder that even in a deep dive like this, we've just scratched the surface.
Right.
There's always more to discover, more to learn, more to think about.
That's the amazing thing about knowledge.
Yeah.
It opens up endless possibilities, inspires us to keep asking questions, seeking answers, pushing the boundaries of what's possible.
Well said. And to our listeners, if this deep dive has made you curious about hemodynamic monitoring, please don't stop here.
Yeah.
There are so many resources online, research articles, you can even talk to healthcare professionals.
Exactly. Knowledge is power, especially when it comes to your health.
That's a great point. So before we finish up this deep dive, I want to leave you with one final thought-provoking question. We've talked a lot about how a patient's position can affect those pressure readings. But what about the internal environment? Could things like, blood viscosity or the diameter of the blood vessels, could those things also impact the accuracy of hemodynamic monitoring?
That's a really interesting question, and it brings up the point that while we strive for precision, the human body is incredibly complex. You're right to consider those internal factors. Blood viscosity, vessel diameter, even the patient's emotional state, those can all play a role.
So it's not just about the tech, but understanding the whole patient.
Exactly. That's where the art of medicine meets the science.
Yeah.
It's about looking at the numbers within the context of the whole patient, their medical history, their physical exam, even their emotional state.
This deep dive has been so insightful. It's amazing to see how technology and human expertise work together in critical care to provide the best possible care.
It has been a pleasure diving into this with you. Remember, the quest for knowledge never ends. Keep exploring, keep asking questions, and never stop learning.
And to all our listeners, thanks for joining us on this deep dive into the world of hemodynamic monitoring.
Oh.
We hope you've gained a deeper understanding of this technology and the people who use it every day to save lives. Until next time, keep diving deep.
It really highlights the fact that, we aim for this precision, but the human body is just so complex. You're absolutely right to think about those internal factors too. Blood viscosity, vessel diameter, even the patient's, emotional state. All those things can have an effect.
So it's not just about the tech itself, it's also about really understanding the individual patient.
Yeah, and all the different variables that are at play.
Exactly.
That's where the art of medicine really meets the science. It's about interpreting those numbers, but doing it in the context of the whole patient, their medical history, their physical exam, and like you said, even their emotional state.
This has been such an eye-opening deep dive. It's really incredible how technology and human expertise have to work together in a place like a critical care unit to give the best care possible.
It has been a pleasure exploring this topic with you. And, never forget that quest for knowledge, it never ends. So keep exploring, keep asking those questions, and don't ever stop learning.
Well said. And to all of our listeners out there, thank you so much for joining us on this deep dive into the world of hemodynamic monitoring. We hope you've gained a new appreciation for this complex but really vital technology and all the skilled professionals who are out there using it every single day to save lives. Until next time, keep diving deep.